आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ।
Hello listeners, you're listening to Vigyan Ki Awaaz podcast program on STEM popularization, catalyzed and supported by the Ministry of Science and Technology, Government of India through its National Council for Science and Technology Communication and Media for Community Foundation. Project devised and designed by Dr. R. Sridhar and assisted by Ashish Tiwari. Local coordination and production, Professor Subramanian. Content writing by Professor Mansa Gowda and post-production by Professor Kaushik P. Kanchan of Garden City University, Bengaluru.
Garden City University, conquer we shall all adversity. GCU, emphasis on life. GCU, emphasis on life.
This is Charvi, your narrator for the podcast. In this episode, we have Dr. ProfBIVAS SAHA, an associate professor at the International Center of Material Science, working in applied physics to develop advanced materials for real-life applications, who spoke about his specializations and his current research.
I am Professor ProfBIVAS SAHA. I am an associate professor at the International Center for Material Science, as well as the Chemistry and Physics of Materials Unit at the Jawaharlal Nehru Center for Advanced Scientific Research. So I've been here as a faculty member in JNC for about 7 years. Before that, I did my PhD from Purdue University in US and postdoctoral research from University of California at Berkeley. What we work on primarily in a broad sense is on applied physics and engineering aspect of materials and materials research, trying to make new materials, make advanced material for devices for real life applications. So we basically make ultra high quality materials, and these materials are designed for applications in light matter interaction, for topological physics, for thermal and thermoelectric energy conversion, and so on. So there are two different aspects in our research. One is related to both fundamental study to look at how different energy and different excitations in materials like electron, lattice vibration or phonon propagate in the material, how they interact with each other, how they give rise to different new and novel phenomena which can be utilized or harnessed for practical application, for energy conversion application, energy transport application, for light emitting and light absorption application. But at the same time, we also work on real life practical devices which have more near term impacts for societal progress. One of our project is basically to deal with the radiative cooling. So as you know, in India and in South India mainly, North India also, Middle East, Asian subcontinent, heating in summer environment has been a major issue, especially the heat island effects, which is that in cities, because you have so much concrete, so much construction all around us, and they absorb sunlight very heavily. The cities basically heats up very much. So what we are trying to do is that we are using our optics or design principle in creating paints which cool surfaces, which cools materials or wherever you put them radiatively, and these are passive, so you don't have to spend electricity. So that is one of our real life application research, where we take our basic knowledge in materials physics, chemistry, and apply it to making real life devices to create cooling. We have succeeded in recently, and we can make now paints which cool the surfaces compared to uncooled surfaces for about 10 degrees C. We have published, we have a patent, there are wide scale media coverage also that has happened over the last 2 years, and we are now working with at least 2 to 3 industrial collaborators to take the paint forward and take it in the market. In fundamental science, of course, that's our core strength, and that is the core strength of JNCASR and sort of like TST institutions, where we have now done several landmark research on new materials, trying to understand the properties of these new materials in terms of how electron and phonon couple, new physics in terms of metal insulator transition, in terms of Wigner crystallization. so on and so forth. So that's broadly my background, and that's broadly what we do research on. All this research are done basically by students. We have around 12 to 13 very hardworking PhD plus masters plus postdoctoral students in our lab. We are primarily an experimental research group. About 80% of the work that we do is in the domain of experiment, but at the same time we have around 20% research thrust, which is on simulation and computation, basically to explain the experimental results or predict new things.
Dr. Bibhash Saha spoke about the relevance of his research and how it is going to help the generations to come.
There are certain things which are in the basic sciences part of our research which have long-term prospects, and then there are certain things which are very short-term prospect. Our cooling on radiative cooling, which is basically, as I was explaining, that urban areas heat up very much, every surface heats up very much. We have developed these paints, and these paints could really in the short term give lot of relief to people, especially in poor areas where it is much difficult to buy air conditioner or other cooling devices, and electricity consumption also are a bit challenging. Our radiative cooling paints can give immediate solution for them, which is going to be applicable in all parts of India. So these are short-term impacts of our research. These are the research we are doing with an industry partner to really take it to the market. But the long-term, some of the work that we are doing in terms of understanding materials property, making new materials, making new devices. These are the research which are directed towards the next generation of electronics and optoelectronic devices. As you would probably know that India currently imports most of our required semiconductor technology, integrated circuit. There are recently efforts to build them in India, but again the technology and the technological foundations are all developed outside, maybe 10, 20, 50 years back. What we are doing is that we are creating now this technological solution in India, and we are at par with the global technology progress, what they have done. So our materials and our devices are also functioning with as good a property, as good a performance as outside, which will surely translate into practical device applications in electronics, IC industry, semiconductor industry in the coming days. So both in the near term and the short term, we are working in this regard.
Dr. Bibhash Saha then continued to talk about the current state of research and developments that might take place in the near future.
So in my own research field, for example, semiconductors, of course, we start with a very, our history on semiconductor research has been there, but not probably that much. Recently, we have picked up speed very fast, and in terms of the devices, in terms of the materials, we are mainly there. We can compete with globally, but obviously the idea is basically to now translate this knowledge into real products and devices for generation of wealth and opportunity for our country, and that is the part we are still trying. Government is still trying. That's the direction we are moving in. In terms of the research in some of the other optics and optics related product, unfortunately we have lot of technical skill, but then there are very little opportunity to convert them into real market based products. But I really hope with the development of semiconductor technology, quantum technology, and government's push for them, this emerging research direction also will come up very quickly. Finally, and one of the most importantly, in this age of artificial intelligence, as you may have seen, there is a huge race going on around the world. Who will be the powerhouse for artificial intelligence? If you really break them up, artificial intelligence and those devices, these are again semiconductor devices, optoelectronic devices, radiative cooling devices. Basically, try to learn and understand how semiconductor works, how materials work, and then basically translate into software-based devices. And in AI, of course, we are a little behind. Recent developments around the world would definitely show that. But progress are happening very fast, and we are really hopeful in 5 to 10 years we'll be in a much better shape than where we are today.
This is Sharvi, your narrator for the podcast. You were listening to Vigyan Ki Awaaz, a podcast on STEM popularization catalyzed and supported by National Council for Science and Technology Communication, Government of India. Tune in for more such episodes to Vigyan Ki Awaaz on this platform and also through Spotify, YouTube and Apple Music platforms. Vigyan Ki Awaaz.
आइए हम सुने विज्ञान की अनकही